Okay, next example. This time we have, I'm going to use function notation this time to make sure we're comfortable with both. So we can say that y is equal to f of g of x, where the inside function, g of x is equal to -3 times x to the power of 4, and f of x is equal to e to the x, right? We can see that if we substitute g of x as f of x, sorry, g of x as x in f of x, then we end up with our y. All right, so y prime of x is equal to f prime of g of x multiplied by g prime of x. So what's f prime of g of x? Well, it is, well, f prime of x is equal to e to the x, right? So if we replace the x with a g of x, we get that f prime of g of x is equal to e to the power of -3x to the power of 4. Okay, so e to the power of e to the power of -3 times x to the power of 4. Now the second part, g prime of x, well, we just apply the power rule. So -3 times 4 is -12. And now we have x to the power of 4 minus 1, which is 3. So just tidying this up a little, 12 times x cubed times e to the power of -3x to the power of 4. Okay, and again, we could have just looked at our original function and gone, okay, y prime of x is equal to a derivative of e to the power of anything. You just first write down e to the power of anything multiplied by the derivative of that thing, which is -12x to the power of 3. Okay, and you can see that this is the same as this. So instead of 5 lines of writing, you have 1 or 2. Okay, next example. Okay, this time let's use Leibniz notation because I think it's clearer. So y is equal to e to the power of u. U is equal to 1 over x plus 4x. dy du is e to the u. du dx is, so 1 over x is equal to x to the power of -1, right? So power rule, -1 comes down, x to the power of -1 minus 1, which is -2. Okay, and then derivative of 4x is 4. So dy dx is dy du times du dx, which is e to the power of u. So u is just 1 over x plus 4x. Okay, du dx is -x to the power of -2 plus 4. You might want to write this as 4 minus 1 over x squared, all multiplied by e to the power of 1 over x plus 4x. Okay, so without writing down these substitutions again, we could have looked at our original function and gone, okay, derivative of e to the power of something. All we do is first copy down e to the power of that thing. Okay, and then chain rule, multiply this by the derivative of that thing, which is -1 times x to the power of -2 plus 4. Okay, so again, this is the same as this. And we obtain the result the same way. Next example, I will rewrite this function as 4 times e to the x plus 2x, all raised to the power of 1/2, right? So we can see this as a power function more easily, or as a composite power function. So dy dx, okay, we bring the exponent down, 1/2 times that whole thing to the power of 1/2 minus 1, which is -1/2. Okay, chain rule, multiply this by the derivative of the inside, which is, so constant stays, derivative of e to the x is just e to the x. Again, constant stays, derivative of x is 1. So that's it. And then just copy this down. And we can rewrite this as, so 4 e to the x plus 2 over 2, and then a negative index becomes a positive index if we put it in the denominator. Right, we can divide the denominator and numerator by 2, so we get 2 e to the x plus 1 over 4 e to the x plus 2x. Okay, so that's it. All right, this next example looks a little bit confusing. We remember that the derivative of e to the x is just e to the x. So dy dx is equal to e to the x plus, now x to the power of e. What is e? It's a real number. So we can apply the power rule, okay? Index comes down, e times x to the power of e minus 1. That's it. Next example. All right, so you might have noticed that I stopped making the substitutions each time because after some practice, it's simply not necessary. Again, derivative of e to the power of something. First of all, you just copy that down, okay? And then multiply it by the derivative of that function, which is, so derivative of sine is cosine, right? So that's our answer. Cosine x times, or I'll just leave it like that. There's no point rearranging. All right. Once again, composite function with a function of x as the exponent. Okay, dy dx is equal to, when it comes to e, just copy that down first. Now, take the derivative of that function being sine of 3x squared plus x. So now we need to apply the chain rule within the chain rule. So derivative of sine, once again, it's cosine, okay? But first we just write down everything in that bracket as the argument of cosine, and then take the derivative of that inside function. So applying the power function, we end up with 6x plus 1. Okay, so we have 6x plus 1 multiplied by e to the sine 3x squared plus x times cosine 3x squared plus x. Final example. A derivative of cosine is negative sine, so negative sine of 2x. Now by chain rule, we have to take the derivative of this inside, which is 2. Okay, so just put it here. Plus, once again, chain rule. Derivative of log base e of x is equal to 1 over x. But here we have a composite function. So we first of all go 1 over root x. Now the derivative of the inside, which is root x, is just 1/2 times x to the power of negative 1/2. Okay, we can clean this up a little by getting rid of the negative exponent. So this becomes 1 over 2 root x times root x, or negative 2 sine 2x plus 1 over 2x. That's it.